This is video 5.1, and the goal of this video is to review how to factor polynomials. So let's take a look at what that means. The instructions will often say factor completely, and factoring polynomials are multiple piece expression. So in this case we have three pieces to it, so we'd call this a trinomial actually, but we're trying to factor this polynomial, and factoring means to rewrite it as a product, something times something, okay, with its factors. And we want to pull out every factor that we can find. So in taking a look at this, first thing I always want to look for is a common factor. So I look at all three of these and I look for something they all have. But 2, 7, and 5, there's nothing they all have. And while these two, meaning, okay, so the only way to multiply to 2, 7, or 5 is to do that single number times 1. So the only thing they have in common is 1, but that doesn't count because 1 goes into everything. The next thing we look for is common x's, and we see an x in the first two terms, but not in the third. So once again, that's not common for all three. So there is no common factor, but we can still factor this by using our generic rectangles and our diamond problem. That's what factoring is. We're breaking it apart into a product by looking at what it multiplies to. So remember, our x squared always goes across from our constant. So this is the x squared term, this is the constant. The additional term, the x term, always goes in the bottom of our diamond problem. So because remember, we're looking for these two corners to add up to negative 7x. And remember, we're also looking for those two corners to multiply to the same thing as those two. So to multiply the same as 10x squared. So now we think about, well, what multiplies to 10x squared but adds to negative 7x? Well, the only way to add to negative is some negatives. And in fact, they're both going to be negative because they multiply to a positive 10x squared. That's one of the best ways to narrow down your choices. So two negative numbers multiplying to 10x squared, adding to negative 7. Well, those two numbers would be negative 5x and negative 2x. So negative 5x, negative 2x. So now we got to fill in the outside of our rectangle. It looks like the best spot for the 5 is going to be here because it affects the two 5's to the right of it. These both have to be x's. One of them has to be 2 to give me 2x. Well, this one has to be 2. And then it looks like this 5 should be negative 5 because x down here times negative 5 will give me negative 5x here. And then this will be negative 1 because negative 1 times 2 is going to give me negative 2x. And then I check my last number, this 5 right here. If I do negative 5 times negative 1, I do in fact get 5. So I check all my corners, it should all work. So the answer is not all this beautiful work I've done, but the answer is rewriting this as a product. So we're going to rewrite this as a product of two binomials. In this case, x minus 1 times 2x minus 5. And I have factored completely. So that's example 1. So remember, we're going to factor it out by using our generic rectangle and diamond problem. So let's take a look at this next one. This next one is interesting because it only has two pieces. But I do the same exact process. I start with my generic rectangle, and I always remember that the x squared goes across from the constant. Now I already mentally checked if anything goes into both 4 and 9, but there is nothing that goes into both of those. Now the big question is, well, what goes down at the bottom here if there's no term? Well, remember, if there's no term, we can think of it as 0 x's, because 0 means nothing. So 0x is what we have to add up to. And then the product, remember, is the product of these two, so negative 36x squared. Because 4x squared times negative 9. So now I figure out what goes in those corners. So multiplies to negative 36x squared adds to 0. So since it multiplies to a negative, one is positive, and it looks like it should be 6 times 6, because those two would add to 0, a negative 6 and a positive 6, and they multiply to negative 36x squared. So in my corners, negative 6x, positive 6x. And now I set up the outside. One thing that I always remember whenever there's a missing term is that your sides over here will be identical. So I think of what times itself will give me 4x squared. And then this one has to be plus 3, and this one has to be minus 3. So notice how these are almost identical, except for the one is a minus and one is a plus. That's very common for when you're missing a term, when you're missing the x term. Not just any term, it has to be the x term. So our final answer, remember, is the product. So 2x minus 3 times 2x plus 3. So whenever you're missing that x term, these two parts will be almost identical. One will be positive and one will be negative. So let's look at one more. One more example. Factoring completely. Here's where that completely word comes in. I remember I'm looking for a common factor, and I look at all three of these, and I think, is there any number that goes into all three? Here's an example where that's the case. In this case, 3 goes into all three of those. That means that this product can be rewritten as 3 times something. So we start with a long and skinny generic rectangle. And we put 3 on the outside because we recognize it's a common factor. And now we fill in the outside. 2x squared, negative 7x, and 5. 3 is a common factor, so we do have to look for that common factor. So this product can be written as 2x squared minus 7x plus 5. That is now factored, but it is not factored completely. It's factored because it's written as a product 3 times something. But it's not factored completely because maybe this part can be factored further. So my answer is probably going to look like 3 parentheses, parentheses. So now I'm going to worry about just this big one and factor that just like I know how using the generic rectangle. So I have in my generic rectangle, my 2 by 2 generic rectangle, I'm going to put the 2x squared and the 5. And I have the outsides of my box. Let's see, I need a sum of negative 7x, and the product is 10x squared. So since it was negative, they both have to be negative, because that's the only way to multiply to a positive. And it looks like I've seen this one already. Negative 5 times negative 2 is positive 10. So negative 5x, negative 2x. So once again, let's see, I'm going to put in my numbers. It's going to be negative 5. This has to be 2, because the 2 can't be at the bottom. And then negative 1. So my final solution is a product of 3 things. The 3, don't forget the 3, that's part of the answer. The x minus 1 and the 2x minus 5. So it's a product of 3 things. 3 we pulled up first, and then we pulled and separated the bigger piece. So it's important to look for that common factor like we saw the 3 here. So do you see the common factor that these all have in common? Can you try this process? I'm going to have you pause the video, try this process, and then restart the video when you're ready to see if you got the right answer before you move on to the other problems. So you should have paused here, and then restart the video when you're ready for the solution. Okay, so hopefully you tried this problem on your own. Here's what you should have noticed. You should have noticed, number 1, that 4 was the greatest common factor. Okay? Yes, 2 also works, but 4 is the biggest, so we do want to pick the biggest. Okay? And once we see the biggest number that goes into all of them, we see a pretty simple polynomial that we're going to have to factor. So this polynomial here is what you're going to factor in the next step using a regular generic rectangle. So that's where we went from there. We fill in the x squared and the 9, and then the 6x, of course, comes down here. And that's what we want to add up to. And we find that it's x plus 3 by x plus 3. So our final answer should be the 4. And then we have x plus 3, x plus 3. Here's your final answer. Now, these pieces are important. If you pulled out a 2, then you would not have been factoring completely. One way you could write this answer is 4x plus 3 squared. And that's how mathematicians will do it, because they want the shortest written answer. And that's the shorthand way to describe x plus 3 times itself, because that is a perfect square. So, your goal is to try the next problems, to always look for that common factor, like we saw the 4 and the 3 on these two examples, and then make sure you ask your teacher if you have questions.